We are going to work on guided practice number 4, and particularly we're going to look at number 1 here. And remember that in module number 4, we are looking to solve problems with ratios, okay? And so we are looking to draw a picture that represents our ratios using one of our techniques. So maybe double number lines, maybe just pictures, maybe tape diagrams, so that we can answer the question that's being asked. In particular, you typically are going to go to tape diagrams here because they are the most versatile. So you'll see that I almost automatically go there, okay? Now you can, particularly in this case, probably go, let's see, like a triple or quadruple number line if you'd like and count things out. That's totally fine. But I'm going to use tape diagrams on these because it is the most versatile and it will kind of quickly get me to the answer using a picture. So let's jump in here. We've got Reagan, Olivia, and Eric sharing a bag of Skittles. We have Olivia ate 3 times what Eric ate, and Reagan ate 2/5 as much as Olivia. So the very first thing that you're always going to see me do is I'm going to pick out those ratios. So we've got this one, number 3, and then over here we have the 2/5. And I'm going to write those down as fractions. So if you turn the number 3 into a fraction, that's going to be 3/1. And then we have 2/5. And then we want to think about what label goes with each of those values. So if I take a look at the number 3, the quantity or the person in this case that comes before it is Olivia. And so Olivia then takes the first spot. So she is the top. And then the second quantity, this time is Eric, is going to be the bottom. Okay, and that's pretty typical for how these go. Unless it's worded something like the fraction of this is that, then it's backwards, okay? But typically, the first thing you see is the top, and the second thing you see is the bottom. If we look at the same thing down here below, we've got Reagan comes before the 2/5, and Olivia comes after. So that means I'm going to label Reagan as the top and Olivia as the bottom. And so now I need to draw a picture for which both of these ratios is true. Well, this is going to be a little bit difficult. And the reason for that is that notice that there is one person who shows up in both ratios, and that person is Olivia. And right now, Olivia is in both ratios, but in one ratio, she's a 3, and the other ratio, she's a 5. And that's going to be a lot more difficult to work with. Now, you can jump in and try to negotiate that. But one of the things that I've been suggesting lately for students is to go ahead and try to fix that right off the bat. So that means I'm going to change my ratios. So they still have the same structure, right? Olivia's still on the top in the first one and the bottom in the second one. But now I want equivalent ratios, but I want the 2 highlighted ones for Olivia to be the same. So if I'm looking at the number 3 and the number 5 for Olivia, I want a number that is compatible with both. So essentially, if you multiply them or find the least common multiple of the 2 of them, then that's what you're looking for. So with 3 and 5, I'm looking for 15. So I'm going to make 15 the value for Olivia in both fractions. That way Olivia gets one number and I know exactly how many boxes to assign to her. In order to do that, then to fill in my other 2 spots, in the first ratio, to go from 3 to 15, I multiplied this by 5. So I'm going to do the same in the bottom so I get an equivalent fraction or equivalent ratio. So that means Eric is going to get 5. And then over here, in order to go from 5 to 15, I'm going to multiply the bottom by 3. And that means I'm also going to multiply the top by 3. And that means that Reagan gets 6. And then I can use the second set of ratios because, again, they are equivalent because we got equivalent fractions. But now each person has a single number and I can assign boxes in that way. So I'm going to have Olivia, Eric, and Reagan. And I'm going to assign their boxes. So Olivia has 15 because that's the number she's got going on in my ratios. All right, do the best that you can there. And then we've got Eric's got 5. Try to make them as proportional as possible so that it kind of matches up, but it's not always perfect. And Reagan gets 6. And so you can see that kind of fixing that issue where a person only has one number in any ratio that they're in allows you to kind of jump into your boxes a little bit quicker. Okay, so it's an option. From here, what I want to do is I want to go to the question that they're asking me. In this case, the question they're asking me is how many Skittles did Olivia eat? But given that Reagan and Eric ate 55 Skittles together, So that means what I need to look at is what Eric and Reagan are together. So Eric and Reagan would be these two. And those two together is going to give me 11 boxes if you count them all up. And they're telling me that that has to be 55 Skittles. So I'm going to set that up as my equivalent ratio. Then I can go ahead and use equivalent ratios to figure out what one box is. So if I divide both sides by 11, I will get that one box is 5 Skittles. From there, I can go ahead and answer their question. Remember that their question is, how many Skittles did Olivia eat? So I'm looking for Olivia, so I'm going to note that down here. And she has 15 boxes. So if I use my idea of multiplying to get an equivalent ratio here, if I take that times 15, let's see, 75 will be the number of Skittles that Olivia ate, okay? And then typically you're going to want to give your answer in a complete sentence. Keep in mind here that I am really looking for all three of these statements. Okay, I'm looking for you to tell me that you took something from your picture and set it equal to something from the problem to set up a ratio. I'm looking for you to go to some reasonable amount of boxes so that you can transfer. Okay, now a lot of times that just means going to one box. And essentially we're finding a unit rate here, as we'll talk about later in later sections. And then using that unit rate to identify another one. What I want you to be careful of, just in terms of presenting your solutions, is I don't want you to skip writing things at the end. Right? You see 11 boxes. Oh, that must mean that each box is 5, and you start writing little 5s in boxes, and then you just give me an answer. Okay. Remember that when you're presenting solutions not for yourself to get an answer, but you're presenting solutions for students to understand. So by identifying each of these three statements, I'm being much more clear about how I'm finding my solution. So make sure that you're including that. When I'm looking for a good presentation of solution, I'm looking for some sort of box representation and then your statements or your equivalent ratios as to how you identified your answer. Okay, so that's what I'm looking for here.